He got a what? A mini cycle?
A cycle.
Oh, a cycle. Okay. Like a unicycle. Okay. A unicycle and a mini fridge. And you got a ukulele.
I got a mini.
Very good. Sky, what was your favorite thing for Christmas?
I got Mortal Kombat a lot.
Ooh. Are you a gamer? Like big time gamer? For real?
Yeah.
Nice.
She has a YouTube channel.
I used to.
My niece is a big gamer girl. She has lots of like gamer girl swag. And for 1 year for Christmas, I got her a t-shirt that said, I went outside once, the graphics weren't that great. She loved it. All right, Sid, how about, no, Savannah on class. How are you? Good. What'd you do for, hang on, listen, Drew. What'd you get for Christmas that was big? Or what was your favorite thing? Yeah, we got a bubble.
Your microphone? Yeah, probably microphone.
A microphone for
She
doing.
also got a DJ kit.
For singing and stuff and recording, or for what are you gonna do with it?
I'm not sure yet.
You don't know yet. Thinking about it. No, you're fine. You can keep it in there. It's probably good to keep it if it's not too crazy. And then how about you, Drew?
The puppy, obviously, and if you don't count that as one, maybe the YouTube camera.
Okay. How about you, Lily?
The money I got, I'm going to use.
Lily's turn.
Like, sorry, I just woke up.
Yeah, I literally just
woke up like this.
How about you, Lily? What was your favorite Christmas thing?
Probably my computer I got.
You got a computer?
Yeah,
What kind of computer?
A laptop.
Wow.
Like a Chromebook, and then I
That's
also got
awesome.
a bike.
A bike? Not, did you grow out of your last one?
Yeah.
Yeah.
I'm getting so much more taller than I
Yes, you are. That's why I asked.
What are you doing with me?
That's awesome.
I stand next to Drew. He's like,
Yeah. Well, Drew can stand to eat a little
Why
more.
does the I know, I should say 2 times.
So that's when I had my first class. Yep. All right, and then Trav. We're on Trav. Good. Drew. Trav's talking. What'd you say?
I got throwing knives.
Throwing knives?
Oh, yeah.
No, for real?
Yeah, I actually got it.
Okay, your parents are super cool. We are not that cool.
Come on, Mom.
Hey, Delia.
Really.
Okay, well, I might give you throwing knives, but your dad would not. No way.
I watched the Axe Throwing World Championships. They were
Mhm.
Did you see the video?
Wait a minute. It's Jackson's turn. What'd you get? What was your big Christmas thing? A Fitbit. That's cool. Have you been using it a lot? Not really? Not yet? Oh, no. That's no good. And how about you?
like, it depends, because like my favorite was like this my leather jacket that I got. But the thing that I use the most is my new headphones.
Oh, nice. What kind of headphones?
Logan.
Cool. That's cool. Delia, what was your big Christmas thing?
Like a gift?
Yeah, or that you did, or whatever. She's gonna really think.
Well, I got some new earrings.
Ooh, that's cool. They're the ones you're wearing? Those are pretty. Butterflies. I love them. Aren't they cool?
Did you get them from Santa? No.
That's cool. Cool. So we got Ozzy. We got Ozzy. He's in the bag to stay warm. So Delia, I was telling everybody before we all started. Let's go over them again. You have four rules for Ozzy. Somebody give me one of them.
I know one.
Wait a minute.
don't pick up the dog.
That's one rule.
Wash your hands before you touch him.
Wash your hands before you touch him. What's another one?
Don't put your fingers in his wire drop things.
Yeah. He's got needle teeth, so anything you leave down, if he's out on the floor, he's gonna bite it. If you put your hand near his face, he might bite it. Wait, what's the last one?
Don't feed him people food.
No people food. That's easy. That's it.
Also, don't touch him on the back because his back is very.
No, he's okay to touch. You just don't want to
pick him up like that.
The reason we don't want to pick him up is because if he squirms and you fall, he could get, like, sometimes people do that with dachshunds and they get paralyzed, and you wouldn't want to be responsible for that. Like, that would be terrible, right? Yes.
I went to Kansas City and I was very excited to go there because of Harper. There's a new baby in our family.
Oh, congratulations. Is it a cousin or what?
Puppy's better. Cousin.
A puppy's better than a cousin? I don't know. Babies are pretty cute. Puppy's better.
No, babies are cute.
Excellent. Yes, hang on, Savannah. I had one more thing to say.
I remembered what my favorite present was.
Oh, yeah?
I got tickets to see Hamilton.
Oh yeah.
Hamilton.
Nice.
A
A really
play.
good musical. Really good musical. That's amazing. When are you going?
April 17th.
That's incredible.
I
You're
have
going to
a
have a good time.
question now.
Yes.
This is some stonks right here. I'm going to use the money that I currently have and money I got for Christmas and money in my allowance and all of my cash, everything I have, to buy all of the Christmas gifts that I did want to give them.
Oh.
Oh, I got one.
Yes.
Well, did anyone see the movie Cats?
Like a microphone.
I did not see
I
it
wanna
yet.
see
Was
it. I
it a
did not.
disaster
I did
everyone
not-
says it
I did
was?
not see it, but I've seen it.
I've seen the
I don't like
musical
the
live,
trailer.
so.
The first
Yeah.
time that Taylor Swift is in a movie, I don't want to see the movie.
Well, here's the
So
thing.
true.
Like, I'm a huge Broadway fan. I saw Cats live on tour, and
Aristocats.
yeah, the thing about Cats is it's really pretty to watch because the choreography's great and the costuming is cool. But there is like zero plot. I mean, zero plot. And I'm not a big Andrew Lloyd Webber fan, and he's the composer for that. So it's not bad music, but it's all based on the poems of T.S. Eliot, so it doesn't necessarily make sense.
We watched.
Okay,
very,
2 more things, and then we're gonna start. Go
We
ahead.
watched the very little of the Star of the Golden Globes, but what I did,
Huh?
like the guy just put
Oh,
a huge
Oh.
burn down.
yeah,
on
I
it.
heard all of that. Hang
It
on,
was
Trav,
beautiful.
and then we're gonna start. What were you gonna say, Trav?
My mom doesn't like the CGI for it because there's just so much, and she's like,
Yeah.
why don't you just make them cats?
I kind of agree. They could have stood
That
to
would
do
probably
that.
have more plot than the play.
Yeah, it probably would
Because
have.
everyone's a cat as good of a cast.
You think? I don't know, man.
People can
Mine,
voice
because
it.
you can cast when it's on DVD.
Okay,
Because
so.
then we don't have to pay for it.
All right, so listen up. Couple things. I'm going to hand you next week's notes. So go ahead and listen. Open your binders. Open your binders to the next empty blank space there. And I'm going to hand you. I have to hole punch these. So basically, I had to kind of I had to run and get these copies made last night. So they're kind of an odd color.
No more pages.
Yep, go to the very back.
Right here.
Yep, it should be right behind what you did today, right?
Are these in color?
No, they're not. Yeah, because I printed them myself here. All right, so listen up. Are you
I
listening?
threw it all away. I'm sorry.
That's all right. You weren't the only one. All right, Eleanor, you listening? Everybody over there listening? Drew, you listening? Okay, so what we're gonna do is I don't have like the whole 9 weeks, which is what I wanted to have, but I don't have it yet. I'm working on it. I was a little distracted by, dog and Christmas, and I was really trying. I was really trying. Plus I've learned that I take my new meds on Sunday night, and within about an hour, I'm useless. And then I'm useless most of Monday as far as anything that involves mental work. So I kind of lost some good, valuable work time because I just get really stupid. Can't think straight and, whatever. It's okay. We'll get it done. So this is for next week. And then what we're going to start doing is, as we are wrapping up the physical science portion of this class, and we start touching on the chemistry portion of this class, your notes are going to get a little more scant, meaning I'm not going to put as much in them. I'm going to want you guys to start adding a little bit. So it's not going to be as much as I'm going to expect from the other group. They're going to have to start like straight up outlining chapters soon. Like they need to start practicing that. So they're going to start getting to that soon. But yours are going to get a lot more blanks, if that makes sense.
That doesn't make sense. That makes me.
But at the same time, it's going to be big idea blanks, because once we get into the chemistry stuff, it's going to be just like at the beginning of the year when there was the earth science business, and it was sort of like high level stuff, not really deep nitty gritty, right? Okay. So
Feel lazy and just want to toss something.
yeah, so today's lab is going to be cool in that you aren't going to have anything to take home. You're going to have did you get one yet? Yeah, okay. You're going to have a project today in lab that you guys are going to do together, and it should be pretty cool. So you're going to do the lab, which is really easy, and then you're going to do a poster. Yes.
Are you going to tell us our lab team?
Yeah, I'm going to tell you right now, and then I'll remind everybody. So lab teams, and the other thing you guys are going to have to do today is come up with, keeping you awake, come up with names. So we've got one that's Michael, Shannon, Savannah, Traveler, Drew. Ethan, Sydney, Ivy, Jack, and Delia. Aaron, Henry, Dylan, Eleanor, Sky. And then Kai, Lily, Cole, Jackson, Lily. Both Lilies. Lily Y, Lily I. You're Lily Y. All right.
Oh, did you say Cole?
Yeah, Kai, Lily, Cole, Jackson, Lily. All right, so let's look today at our notes. Who didn't have notes? Did anybody not have notes? Was anybody unable to find them? Or did everybody find them?
I found mine. I wasn't able to find them, so I had to do it on my mom's computer.
Yeah, he did them on the computer, but that's okay.
Legit.
All right. Okay, so we started talking about what? What was this chapter all about?
What are waves?
Waves, very good. All right, so waves are good because there's going to be a lot in physics that have to do with waves. And then we did the whole chapter, right? It was a lot. And I apologize for it being a lot, but I'm trying to keep you kind of lined up with the other guys so that your labs make sense. If they're doing theirs is a little more broken out differently, but I want your labs to make sense to everybody. So you have lots of vocabulary. So let's look at the vocabulary for a minute, which we don't usually do. So that's on the back side of that first page, right? So talks about a wave and a mechanical wave. So does anybody remember what a mechanical wave has to do? Or what causes a mechanical wave?
Mechanical wave is something that is caused by something that is like a human or machine.
Yeah.
Mechanical waves require a medium.
Right, they require a medium. Right, there you go. So that's the big thing to remember. And it's usually caused by something that's vibrating, right? All right, and then we had, so what would a vibration be? How would you describe that?
Something.
Wait a minute, put your hand up in case somebody else has an answer. Delia has an answer.
A repeated back and forth or up and down motion.
Right. Great, right, very good. All right. So, and then if this were a wave, where would I find the crest and where would I find the trough? Who knows? Delia.
The crest would be like on top, I think.
Yeah, and where would the trough be?
Bottom.
At the bottom. Just like, think about, cows, they drink out of a trough, or horses, they drink out of a trough, and that's down low. And then the crest, like even a wave on the beach, you'd say the crest is up high. Okay, so then can anybody explain in their own words, the difference between a transverse wave and a longitudinal wave? Who gets that? Do you get that, Jack?
Yeah, actually, I do think that a transverse wave is like when you fling a rope or a cord, it goes it's like rolling hills. And then a longitudinal wave is like a spring where it's compact and in a spiral, and when you pull it, it's
this kind of wave.
And also the question, it says longitudinal wave.
Yeah, it was backwards.
So I did do that.
Good. Yeah. No, a couple people caught that. They were wrong they were backwards, and I don't know how I did that. I was cutting and pasting, and I'm sure I cut and pasted in the wrong place. Yes.
I noticed this, and I was going to ask you what type of wave this would be.
Okay.
Because I'm confused about it.
I'm sure you're going to stump me, but go ahead. All right. What?
You see, in Minecraft.
Oh boy.
No, seriously.
Okay. All right.
Minecraft, there are pistons, and they extend one block out, and they can pull one block back in. And if that one block that they pull back in is a redstone block, that seems like a big power source.
Yeah.
In a way, if you attach that to a bunch of pistons, one piston extends, and then it hits the other piston, and then that piston extends, and then it hits the other piston.
So if it's going this way, what would it be?
That would be a longitudinal.
Yeah, that would be a longitudinal wave. Exactly.
Fortnite is old.
Apparently, Fortnite is no longer cool.
Yeah.
But grandparents don't know that because they gave some Fortnite gear for Christmas.
Yeah.
Yeah, it's fine.
Fortnite.
They don't know their grandparents. It's okay.
Yeah, the grandparents gave us all.
All right, so can somebody tell me,
I can see.
so what's a surface wave? Like where would you see that, or Drew, how would you describe it?
A wave on the ocean.
A wave on the ocean would be a good example. What else?
Never mind, he took mine.
So in your book, it talked about the duck. All right. What was important about the duck on the water? Does anybody remember about the duck? Do you remember?
He never moved.
He never moved, right. Have you ever been in a wave pool or the ocean and
Yes.
sitting on a floaty
Yes.
and the wave comes and it goes under you, but you don't move? I mean, you go up and down with the wave, but you don't go forward or backwards.
Sava's never
It
been to the
depends
beach.
on where you're at in the wave pool. 'Cause I was in
Unless-
the wilderness and I was really close, and all I did was float. But if you're like
You can't remember
back
that.
a little bit, you get slammed by the wave. And get
Right.
knocked
So unless you're near the shore. Okay, so why do the waves
when it starts to
closer to the shore, why do they get bigger and carry stuff in? Does anybody remember why that is?
They're adding on top of it.
Yeah, they're adding. So, okay. So imagine
Like
you
a
got
snowball rolling down.
kind of like a snowball rolling down a hill. Where's my marker?
Let's say you make bones.
Oh, I think
Yeah,
like
you
a
can-
bones.
I grab a spare marker.
You gotta roll it down.
That's my spare marker. Oh, I'm sorry, friend.
Yeah,
Oh, there's his name. And a graphic I drew for somebody who wanted an answer for something.
Quarters down the roll.
That's interesting.
This is about swallowing. Oh, and ended up not being his name. We changed it. All right, so look, Drew. So you have the surface like this, okay, and then there's a beach. The beach is like right here, right? This is where put our umbrella up and have a nice time. All right. Ah, there's a beach ball. Oh, we're having a good time. Okay, there's the beach. Can't forget the chair. Gotta have the chair.
Brothers,
All right.
you know.
Nice.
Okay. All right, so.
That actually looks good.
I can't see it.
Ow! I'm sorry.
Oh.
There we go. All right, so out here, you have a wave building. All right. Now it's moving with a certain velocity, right? The speed and direction, and it's headed this way. Correct? Okay. As it starts to get closer and closer, so you've got all these particles, right?
Distance and time.
And as it's moving,
Where's
This-
Jaws?
as it's moving, the energy is getting transferred to the next set of water particles, and it's just moving and moving. But when it gets here,
Turning kinetic
it's
energy.
taken up this much space, right? And it gets down here, and now it's kind of got less room to
It's
work.
kind of like, I think of it as like you're running like a wall, and then there's like a little block, and when it hits,
Yeah.
it starts to tip.
Yeah. So when it gets here, what happens is this wave, which has been coming like this, it starts to slow down. Well, it's the same amount of energy, but your speed is just decreased, right? So now it's not going quite as fast. So these guys kind of catch up with each other, and they start to make bigger waves. And then when it hits the ocean, it's like, I'm gonna crash on your beach.
No,
Scene.
the beach ball.
Yeah, there goes your beach ball.
It kind of looks
Except
like
that they
a
respect the
monster,
beach ball.
like with the way
Yeah, it kinda looks like
a tooth, and it's like a
Ask your
mouth.
mom.
So I saw a bath bomb that was a shark attack bath bomb.
You're saying
It
the
floats.
still there.
It floats, so the shark's head is above the surface, and it had this red stuff in its mouth, so it looks like blood coming. I need to get it. It was hysterical.
Wait, what if it like disperses red stuff into them?
It did. It looked like a shark attack. It was. I need to get one.
Is it gain potential energy or like is it gain potential or losing kinetic? That's a good question. Let's do that. It's a beach or when it's moving with surface. So as it's moving, okay, as it's moving, it's got kinetic energy, right? But the same amount of energy is getting capitalized, is a better word, into a smaller time frame. So the amplitude is increasing. Yes. So I think it's potential energy because when you had it, they kind of bunched up together, yeah, and then all got the potential energy sort of very. So as a whole unit, it's kind of like potential energy. Those individual particles, it's kinetic because they're moving. So if you look at the big picture, you know, and you're on the raft over here, like, do you know how surfers and body surfers, see body surfers and body surfers, they take advantage of that kinetic energy to push them in. Or if you were to hit them, there's potential to push, right? All right, then we have a bunch of other, so we had, right? Let's look at our notes straight up. All right, so does anyone want to read the first paragraph of our notes? Jackie, so you can go next. Waves of energy. Wave of energy. This is going to be a disturbance. Transport energy from place to place. This means that the ability to do work is transferred from a place to a place. A medium is a material which a wave travels. Chemical waves require a medium. Waves are created when a source of energy causes a medium to vibrate. A repeated back and forth or up and down movement is called a wave. It's called a vibration. The repeated back and forth or up and down motion is called a vibration. Right. So let me do the next one, and then you do the one after me. All right. So types of waves. Waves are classified according to how they move. Hey guys, can you wind down a bit? Sure. Waves are classified according to how they move. Three types of waves are transverse waves, longitudinal waves, and surface waves. So transverse waves, go ahead.
Travels through a medium is at right angles to the direction in which the wave travels.
Yeah, we should take the is out of there. That's a typo. Okay, keep going.
The crest is the highest point of the wave above rest position. The trump is the lowest
Trough.
point of the wave below rest position. The tip of the wave
Looks like you have a little baby.
Shake a sheet, right? You know when you shake a sheet like this?
Yeah.
So let's see. Savannah, I'm gonna borrow you. So let's see. Beep beep, I'm a sheet. Here, you take that in. Okay. If I hold it still, can you make transverse waves? There you go. She's got it.
Oh, that's cool.
So exciting. Yep. So you hold it really tight, or somewhat tight, right about there. Now, have you ever seen when you get it going really fast and it looks almost still? That's how you get your standing wave. Yeah, it does kind of. All right. So then, who wants to read longitudinal? Anybody volunteer for that?
Can I explain it?
Oh, go ahead, Eleanor.
Where does it say?
Longitudinal waves, right there.
Longitudinal waves move the particles of the medium parallel to the direction in which the wave travels. Compression is an area where particles are spaced closer together.
Mm-hmm. What's the next one? What's it keep saying? Keep going.
And rarefaction is area in a medium where particles turn out. Think of the waves you make when pushing on a string.
Here you
not
go.
Flushing on a string.
Take that in. Okay, now hold it right there. All right. It's harder to do unless it's perfectly straight. How about here? Wait a minute, wait a minute. Hang on.
Tap one end.
I know, hold on, wait. There's a way to get it to go. Sometimes, hang on, it's harder to do, but you can make it. Little bit. Let me see if you let go. Sometimes let go. Sometimes if you stretch it out like this, you can see it better. There you go. See it?
Whoa!
Now, do you notice that it goes down? Can you guys see over there? It went down.
This is similar thing to the Newton's trail too, right?
And it comes back. Why is it back? Why is it coming back?
Back down.
What do you call that? But why does it come back? There's a word for that.
Reflection.
It's reflection. Very good.
Oh!
Now, here's what happens if we talked about this. The book talks about interference. Okay, now watch. Hang on. If you do it too fast, you watch. Sometimes what you'll get. Can you guys over there see? So if you watch this,
together, and then if either it
there you go, buddy.
both or
So it can, if you time it right, you can. Whoop, if you time it right, you can get bigger waves. If you time it wrong, you get crazy looking ones, right? So here's the nice, simple one.
Yeah.
See how big that compression is in the middle? Because we got it timed nicely. And when it doesn't show up, it's not timed very nicely. Now look at that. There's two of them. See that? You're starting to get the weird interference. Isn't that cool though?
Cool.
I know. I could play with it all day.
I actually listened to
That
the
was
sound
sad.
of waves that made me go to sleep last night.
So I do that every night. So surface waves are a combination of transverse and longitudinal waves. They travel along a surface separating two media. So you can see surface waves and earthquakes. So if you look at the graphic there, there's two different types of surface waves. There's love waves and Rayleigh waves. And you don't really need to know that, but I'm just showing you. Love waves, yeah. And Rayleigh wave. They're named after the people who discovered them or decided to name them. All right, so this next part, properties of waves. The basic properties of waves are amplitude, wavelength, frequency, and speed. So what do you call the time required for one cycle? A complete motion that returns to a starting point. What's the word for that?
A period.
Very good. All right. What's the maximum distance? Let me do it this way. Let's do it this way. Somebody who wants to volunteer to come up?
I volunteer to be
Your chat.
I volunteer to be.
Okay. Okay.
Excuse me, what am
I
I doing?
volunteer.
All right.
Like, sorry, I just woke up.
So you have chosen.
Label for me the amplitude. Where would you find amplitude?
Where's the puppy?
In the back.
Yeah, from where to where? How would you measure it? Help him out if he's not sure. Where would you find the amplitude?
It's above the resting point.
Top.
Below the.
So from here to here. Just do a line. So this amplitude, very good.
And then
You
the
could also
wavelength.
see it from here. Wait a minute, Drew.
Can I
From
try
no, let him do it. From there to there. Whoop, there it goes. Yeah, there you go. Where would you find the wavelength? Do you know where you can see wavelength?
Yes.
Yeah, from here to right there at the tippy top, right? So there's going to be our wavelength. Now, don't go anywhere. And this is my point in time. Okay, this is an imaginary point in time. And this wave is coming through here like this. And I am trying to see how many times this wave passes through here in a given unit of time. What am I looking for? The wave's what? What are we looking for? We want to know. Basically, it's asking how fast is it moving. What is it called?
It's. I know what it is. I know what it is.
Jackson?
The frequency.
Frequency.
That's what it was.
All right. And then what do we measure frequency with?
Hertz.
Hertz. Okay. Thanks, Trav. All right. So this
I know, I was about to say, that hurts.
amplitude. This is the wavelength. This would be the frequency. And then we measure that in hertz. Now, here's something to look at. Let's look real quick. Hang on a second, Jack. Look down there at the bottom of the page. I have
Look, I made a wave.
examples of, yep, I have examples for you, which kind of like what we just drew, right? Oh, and there's the crest and the trough. We already kind of went over that. So look at the piano keyboard. Y'all see the piano keyboard? You see it? Okay.
I don't have it right now.
Oh, you don't? I gave it to you. Should be in there.
Oh, that was part of the thing.
Yeah. Y'all see? Hello. Okay, if you see the piano keyboard, where's my phone? Oh, let me show you. Let me grab my phone. I'm gonna show you something neat.
Where's
So,
the puppy?
he's chilling in here. He likes to snuggle
No,
up.
it's actually just not the stuff that you gave me.
He's still really tiny, so he's good at snuggling up. So, hang on, Jack. I'll come back to you in a second.
Actually not part of the thing.
All right. Do you all see?
It's not there.
Well, that's next week's lesson, I think. I don't know. Whatever. So anyway, there's a piano keyboard. It looks like, look on with Jackson, okay? All right. Now, do you guys see in the middle there? Do you see in the middle there where middle C is? Okay, so middle C on a piano, that's where you find it. And if you look, there's a number.
Middle C?
That number is the hertz for it. Now, if you look at A4, so the octaves, you can see the octaves have numbers. There's an A0 and then all the way on the left, and a B0, and then there's C1 through B1, right? C2 through B2. Do you see it? C3 through B3, and then C4, that's right in the middle, because the highest is going to be C8. Okay? So do you see A4? Do you see it?
Yeah.
Okay.
Wait. I don't see it.
You see A4?
Is A? It looks like A.
It says A. Yeah, it looks like AA. What's the number for that?
I found it.
What's the hertz reading for A4?
44.
Delia?
I see it. Never mind. 493.
Oh, that's B4. Look right next to it. A4.
440.
Yep. That's it. So A4 is known as A440. And if you can very often hear musicians will tune to A440. A440 sounds like this. That's A440. Okay? Now, here's the cool stuff.
That's also the same. That's actually the same octave of note that they use.
And if you look right here, it'll say A.
So
What?
I said I'm pretty sure that's the same note that they use too when a human dies. On the little monitor thing.
Yeah, it's like.
Oh, it sounds like a flat line. Okay, yeah.
Oh yeah.
So there's A440 right there. All right, so here it is again. Listen. Okay.
Yeah.
Now,
Yeah, it does.
here's the cool thing. So I have what's called a visual tuner on my phone because I'm a singer, right? So I have this visual tuner, and what it does is whatever note you're singing, it shows you on a scale, and it lets you know exactly where you are. So you can basically, it'll tell you where you talk, it'll tell you everything. It's how there's some people that are hearing impaired that sing. Like there was a girl on one of those talent shows a couple years ago who was almost entirely deaf. And that's how she learned music, was with a visual tuner. It's really kind of cool. Years ago, I have to find you the picture because it's way cool. But years ago, I caught like a virus that gave me laryngitis. Okay, it was just yucky. And laryngitis is when your vocal cords, you can't talk very well. Well, by this point, I was back to speaking, but I still couldn't sing well. And I went to this, it's a voice therapist. There's actually such a thing. And I went to this voice therapist, and I was like, hey, all right. And I said, yeah. They said,
What's your problem? And I said, my problem is right around A natural.
maybe A sharp. Well, if you look, like A natural is 440, right? And A sharp is 466.16. But I said, it's around A natural. So they had me, they put a camera in my mouth, a long camera. It didn't hurt. I had to just keep my mouth open, and they put it all the way to the back of my mouth, and it shined a really bright light, and it looked right down my throat at my vocal cords. And then they had me do like, all this stuff, and the image was on a screen in front of me, so I could see my vocal cords vibrating and moving. But the coolest thing was there was a point where my voice made like a bumpy sound that's what I'd been dealing with. And they found it and froze it, and it was 446 hertz. And she said, well, you're good when you said it was A natural because you were nearly on it. But that note, so let me show you this visual tuner. That's what I'm going to have you do. All right, so now, all right. Do we remember? Who can remember where that note was? Raise your hand if you think you know where it was.
Wait, that what?
That we just heard it.
Oh, I
Okay. Now I want you to. Here's where it should show up. Right here. So can we all do it? There we go. Good. Perfect. So you all found it. You saw right at the top it said A4. Yep. All right. So that means that your vocal cords down in your pharynx down here are vibrating at 440 hertz. 440 vibrations per second is pretty darn cool.
440 shakes per second.
Pretty much. So if you look at the next thing, it says
Wait, how many hertz is like
the
a
speed.
phone vibrating?
Hey, we got 3 minutes.
Thank you.
The speed, wavelength, and frequency of a wave are related to each other by a mathematical formula. And then it has it, wave speed equals wavelength times frequency. And we have another one of those handy triangles. All right, the next bit of your stuff here, I'm just going to read through it, and I want you to check and make sure you have the right things filled in your blanks, okay? So when an object or wave hits a surface through which it cannot pass, it bounces back. This is called reflection. An incoming wave can be called an incidence wave. Imagine a parallel line connecting the two surfaces at right angles. The space created between the incidence wave and the imaginary line is called incidence angles. On the opposite side of the imaginary line, the reflecting wave bounces away from the reflecting surface. The space between the imaginary line and the reflecting ray is called the angle of reflection. When a wave moves from one medium into another medium at an angle, it changes its speed as it enters a second medium, which causes it to bend. The bending of waves due to a change in its speed is called refraction. When a wave passes through a barrier or moves through a hole in a barrier, it bends and spreads out. The bending of waves around the edge of a barrier is called diffraction. Yeah, hold on a second. Oh, go ahead. Go ahead.
So that second blank was
Incidence angle.
Oh.
Mm-hmm.
I put angle of incidence.
That's same thing.
Okay.
That's fine.
What angle of reflection?
No, that would be the next one. The next one will be angle of reflection. All right, so when two or more waves meet, they interact largely based on how their wavelengths align. So that's what we did that with the spring, right? It's called interference, and constructive interference is when they combine, make a bigger wave. Destructive interference is when they combine to create a weaker wave. And if you look over there on the right, you can see a visual of it. Do you see how the constructive interference, the wavelengths are exactly in the same place, right? It goes like this, right? They go together, as opposed to the next one where they kind of do this sort of thing, right? If the incoming wave and the reflected wave combine in the right places, a standing wave which appears to be standing still is created. These points are called antinodes. Nodes occur in the same place on a wave near a resting point. Antinodes occur at the maximum points on the crest and troughs. So when Savannah and I were shaking that rope and it got to look almost blurry and there was that one point in the middle that never moved, did you see that?
No.
Yeah.
That was your node.
That's why it looked like a DNA strand, because it was kind
Yeah,
of
that one
twisted
point
in the
didn't
middle.
move, right? So that's your node there. And then most objects have a natural frequency at which their particles naturally vibrate, and that's called a resonant frequency. Resonance occurs when vibrations traveling through an object match its natural frequency. So real quick before we end, I want to explain something about resonance and resonant frequency. So every object has a natural frequency at which it vibrates. And this is why you can take a glass. You ever seen people like wet their finger and run around the top of a crystal glass? And it goes, whoo, right? There's that. And then have you ever seen like an opera singer break a glass without even touching it?
I've seen that movie.
You don't think that's an opera singer?
Yes, you can do it. You can do it. It has to be very fine, very thin crystal. But if you can find,
You have to find its resonant frequency.
What? No, it's not screaming very loud. Listen. Here's how you do it. And I may show you if we have time, or maybe next week I'll show you. But if you take a crystal glass and you flick it, it'll make a tone, right? Then your job is to repeat that tone exactly the same. And if you do it correctly, when you stop making a sound, you'll hear the glass continue to make the sound even if you never touched it. It'll start vibrating just from your vibrations from your voice. And it'll be like humming all by itself. But if you do that enough and the crystal is fragile enough, it can break. The other thing is about resonant frequency is it needs to be taken into account when you're building structures. So it talked about, in your book, it talked about troops marching across a bridge, right? They can't march in step because you can cause problems with the bridge. There is a bridge called, shoot, I can't remember what it's called, but I'll look it up for you. There's a bridge that is famous because it basically fell apart like as soon as it was open.
Why an earthquake?
No, it wasn't an earthquake.
What?
It was just traffic and wind. So the resonant frequency of the structure was reached and the bridge went absolutely insane and all the cables flipped off. It looks unreal. It looks like CGI.
Wait, it looks like Doctor Strange when like he's moving buildings.
True. So the last, hang on, wait a minute. The last part on seismic waves, let me read this to you real quick, okay? And then I'll find that video.
So
Drew. When the stress in rocks builds up enough, the rock breaks and changes shape, releasing energy in the form of waves or vibrations. That's an earthquake, and we call those what kind of waves? Seismic, right? You got longitudinal seismic waves are called primary waves or P waves. Transverse seismic waves are called secondary waves or S waves. And let's see. And then when S waves and P waves reach the surface, they form your surface wave. So an example of a surface wave is a tsunami, which is created the same kind of way we drew up here, except that it's usually like an earthquake under the surface of the ocean, or maybe a volcanic explosion.
I watched a movie
causes
about,
really big
like, a
ones.
tsunami
Yeah.
and family got separated. It was really
Earthquakes are detected by seismographs. All right, so real quick, I'm gonna find a video of that bridge for you.
Can I tell you
Oh yeah, and one other thing. I need to double check and make sure that your test is activated for this week. So if you go online tonight to look for it and you don't see it, just give me a little bit, because it just hit me that maybe I didn't turn that on yet. Go ahead while I find this.
Me?
Yeah, go ahead. Say what you're gonna say.
It's a joke about the hertz.
Okay,
So it
the
says-
hertz.
Yeah, it's a hertz, the unit.
Uh-huh.
I got so this dude. I was working at this is hypothetical. I was working at this car rental place, and this dude told me a story. He said I got hurt, and I needed to get to the Hertz car rental and get to
Tacoma
the
Narrows.
doctor.
Wait a minute.
It was a bad joke, but
That's
still,
funny.
it worked.
So hang on. Drew. Okay, so it was the Tacoma Narrows Bridge. I knew I couldn't remember the name of it. And it was in 1940, but this is what happened to it. And it was wild. I mean, just absolutely wild. And this is all what happened. Yep, this is what happens. Can everybody see? When a resonant frequency of a structure is reached.
She can't see. Delia can't see.
Okay, I'm scooting back.
The puppy wants to see this.
He's fine.
Yeah, the puppy.
Wait, look.
So the bridge was built so it wouldn't fall apart. But
Well, all bridges are built so they won't fall apart. That's kind of the idea.
That's true, but.
But once they had it up,
So what bridge was this?
it's called the Tacoma Narrows Bridge.
There was an attempt and there was a failure. I thought this
It
was
was a
the
high
bridge where.
Is this the one? No, wait a minute. Are they going to show it shake? I maybe pulled up one that didn't show the shaking.
If you looked at it from
Let me
the front,
fast forward
it would
here.
twist, like,
Oh, here we go.
upside down and go shoot.
Here we go. So here they opened it. Now people are driving on it. Disaster.
Great representation.
Look at that. Where's the bridge?
Oh my God, it does look like CGI.
See, that doesn't even look real, does it?
Can't see the bridge.
You can't see the bridge?
They
Sure, no sound issue.
have a good angle at it at some point.
Watch.
It's false.
It's not playing.
Oh, did I pause it?
Yeah.
Then don't watch. Okay, wait.
The 6 million test ban took a year to build. It's still paused.
Play.
No.
Look on it. I tapped it wrong.
It's paused.
There's our disaster.
Where's the bridge destroyed?
Watch
So
it.
this is a steel bridge, right?
Oh,
Supposed to be.
Isn't it?
Yeah, it's steel.
Isn't the
Mhm.
Brooklyn Bridge and the
Look at that.
Bridge
It
the
looks like
same thing?
CGI.
Isn't that crazy?
It looks like CGI.
Look at it. So wait a minute. So listen. So the boys' gymnastics coach is also an architect, and he got a panicked call one night from the Omni in Atlanta, which used to be like a big concert venue, that the entire building, they were afraid something was wrong with the structure of the building, and he ran down there to check. And apparently there was a band that night, and the crowd was jumping to the beat, and it was just right. And it caused the whole floor to do this while everybody was on it. Like it turned almost liquid, right? It was like waves, the floor was moving. And they panicked, and he's like, this is a resonant frequency problem. But I mean, look at that. Look at that's a big bridge. See, the cables are like snapping.
This is a
Right?
steel bridge, and the
It's
Golden Gate
so
Bridge and the
steel.
Brooklyn Bridge
No, I mean,
are
like, it's
steel
still-
bridges. Is it because those bridges are longer that they don't do that?
Well, they aren't they're constructed in ways that stop the vibrations from traveling everywhere. Boom.
I thought it was the bridge. Did you know that the bridge where they...
right, we need to start math.
Did you know that the bridge...
Hang on a second, she's talking.
Did you know that the bridge that you used to put love locks on fell down?
Which one?
Remember where you used to put locks on it that say like...
They do it on a lot of bridges. I'm just
Yeah,
wondering
but
which
the
one
main
you're.
bridge was in Paris.
Okay.
That fell down.
Did it? Okay.